Let's start section 8.2 today. Consider the balances below. What is the value of each shape? Explain why. I want you to pause the video and try to solve for the value for a triangle, a square, and a circle. Now let's try this together. There's several ways to do this problem. This is just one way. I noticed that a triangle plus a square is equal to 12. And we have a triangle and a square in the second balance. So we can say a circle plus a circle plus a triangle and a square, which has a value of 12, should be equal to 18. Now to prevent any confusion, let's put an underline underneath our circles so we don't confuse it with the number 0. I can subtract 12 to both sides. And this will imply that a circle plus another circle is going to be equal to 6. Since 2 circles is equal to 6, well, that implies that a circle has a value of 3. So that solves for one of the shapes already. In the third balance beam, notice we have 2 circles. I can say a triangle plus 2 circles, or 3 plus 3, since the value of each circle is equivalent to 3, is now equal to 10. So I'm replacing these circles with its actual value, which is 3 each. This implies that a square plus 6 is equal to 10. And I can subtract 6 to both sides to solve for that square. A square must be equivalent to 4. Now that's great. We solved for another shape, and we can finally solve for the value of a triangle. A triangle plus a square is equal to 12, but we know a square has a value of 4. So a triangle plus 4 should be equal to 12. And I could subtract 4 to both sides, and we know a triangle is equivalent to 8. And that completes question 1. We know a triangle is worth 8, a circle is worth 3, and a square is worth 4. Question number 2, solving equations. Solve each of the following if possible. The first step is to isolate the variable. So let's add the square root of 3 to both sides of the equation. So we have now x is equal to 21 plus the square root of 3. We cannot add 21 and the square root of 3 together, so that completes our solution for question 2. For question number 3, we have 2x plus 5 over 2 is equal to x plus 25. Again, I want to isolate the x variable, so let's get that on one side. Let's subtract x to both sides first. And this gives me x plus 5 halves is equal to 25. We can subtract 5 over 2 to both sides. We'll subtract 5 over 2 to both sides. X is equal to 25 minus 5 over 2. So let's put a 1 underneath this 25, and we'll multiply the top and bottom of this fraction by 2. And so we have x is equal to 50 over 2 minus 5 over 2. And that simplifies as 45 over 2, which is a great solution. Our answer is x equals 45 over 2. 45 over 2 is a good solution, but you could always convert this to a mixed number. This is equivalent to 22 and 1/2 as well. So these are both good solutions. Question number 4. We have 5 times the quantity 2x plus 1 plus 7 times the quantity 2x plus 1 equals 84. I'm going to start by distributing the 5. 5 times 2x is 10x. 5 times 1 is 5. 7 times 2x is 14x. 7 times 1 is 7. And now we can collect like terms. 10x plus 14x, that gives me 24x together. And 5 plus 7, that's equivalent to 12. And now we have to isolate the x variable. Let's subtract 12 to both sides. We'll subtract 12 to both sides. 24x is equal to 72. Now we can divide both sides by 24. And x is equal to 72 over 24. But we can simplify this. In question 5, we have 7 times the quantity 3x plus 6 plus 5 times the quantity 3x plus 6 equals the square root of 144. I'll start by distributing the 7 and we'll also distribute the 5 at the same time. This simplifies to 7 times 3x, which is 21x. 7 times 6 is 42. 5 times 3x is 15x. And 5 times 6 is 30. We know the square root of 144 can be simplified as 12. And now I can collect like terms. 21x plus 15x, that gives me 36x. 42 and 30, that adds up to 72, and this is equal to 12. We can now subtract 72 to both sides. This simplifies to 36x equals 12 minus 72, that's negative 60. And now we can divide both sides by 36. Let's divide both sides by 36. X is equal to negative 60 over 36. But we can reduce this further. Let's divide the numerator by 12 and the denominator by 12. This simplifies to x equals negative 5 over 3. In the last 4 questions of this worksheet, we have application problems. You're welcome to pause the video at any moment and try any of these questions on your own. So let's get started. Question 6. For a particular event, 812 tickets were sold for a total of $1,912. If students paid $2 per ticket and non-students paid $3 per ticket, how many student tickets were sold? To start the problem, let's give some variables names. We'll let x equal the number of student tickets sold, and I'm going to let y be equal to the number of non-student tickets sold. So we'll start by labeling our variables x and y, and we know that for this problem, 812 tickets were sold to both students and non-students. That allows me to create our very first equation. X plus y is equal to 812. I know the number of tickets sold to students plus the number of tickets sold to non-students must add up to 812. That's our very first equation. Now to generate our second equation, we know that the students paid $2 per ticket and the non-students paid $3 per ticket. That means in order to figure out how much money we get from the students altogether, we're going to take 2 and multiply it by the number of students. That's 2x. And then we'll add 3 times y, which is $3 sold to non-students. So we can add 2x plus 3y, and that should add up to 1,912. The money generated from students plus the money generated from non-students has to add up to $1,912. Now to solve for either x or y, we have to solve for one of the variables first. I'm going to solve for y and then substitute it into the second equation. Let's subtract x to both sides. And this gives me y is equal to 812 minus x. I'm going to take 812 minus x and substitute it into the second equation for y. This simplifies as 2x plus 3 times, now we're going to substitute 812 minus x into the y, and that's is equal to 1912. Let's distribute the 3 now to the parentheses, and we have 2x plus 3 times 812 is equivalent to 2,436, and 3 times negative x is negative 3x, and that's equal to 1,912. Let's collect like terms. I can add that 2x and that negative 3x together. That's negative x plus 2,436 is equal to 1,912. Let's subtract 2,436 to both sides. And so negative x is equal to negative 524. And finally, we'll divide both sides by negative 1 to solve for x. X is equal to 524. So we know there are 524 student tickets sold. And if we want to know how many non-student tickets sold, we can solve for y. But that's all we want for this question. We are done with question 6. Question 7. A 10-foot board is to be cut into 3 pieces, 2 of equal length ones, and the third is 3 inches shorter than each of the other 2. If the cutting does not result in any length being lost, how long are the pieces? Now, a lot of people missed question 7. The reason is we have 10 feet here and 3 inches here, so the units are not the same. So the first step is to recall that 12 inches is equal to 1 foot. So I have to convert that 10 feet into inches. So 10 feet is equivalent to 120 inches. So that's the first step. Now we're going to take a 10-foot board, which is equivalent to 120 inches, and we're going to break it into 3 pieces. So let's draw a picture of what this looks like. The first piece has to be equal to the second piece. So let's call this x, and this second piece x. The third piece has to be 3 inches shorter. So let's call this x minus 3 because it's 3 inches shorter in length. Now let's come up with an equation. I know x plus x minus 3 has to be equal to 120 inches. We could collect like terms. X plus x is 3x. And we now have 3x minus 3 equals 120. Let's add the 3 to both sides. 3x is equal to 123. Now we can divide both sides by 3. X is equal to 123 over 3. And this simplifies to 41. Now x is equal to 41. That represents this length here. So this must be 41 inches. This must be 41 inches as well. And the third piece has to be 3 inches shorter. So 3 inches shorter than 41 is 38 inches. So we now know that we have 2 pieces that are 41 inches, and the third piece is 38 inches because it's 3 inches shorter. Number 8. Miriam is 10 years older than Ricardo. 2 years ago, Miriam was 3 times as old as Ricardo is now. How old are they now? Let's let M represent Miriam's age now. And we'll let R represent Ricardo's age now. Let's come up with some equations. I know Miriam is 10 years older than Ricardo. So we can add 10 years to Ricardo's age just to equal Miriam's age. So R plus 10 is equal to M. And if I subtract 10 to both sides, I get Ricardo is Miriam's age minus 10, which makes perfect sense. So we know R, or Ricardo's age, is M minus 10. Now let's look into details. 2 years ago, Miriam was 3 times as old as Ricardo is now. So 2 years ago would be Miriam's age minus 2. That's going to be equal to 3 times Ricardo's age now. So that's our equation that we can set up here. But I know R is equivalent to M minus 10. We solved for that earlier. So we can replace this R with M minus 10. Let's take this and substitute into here. We have M minus 2 is equal to 3 times M minus 10. Let's distribute the 3 to the right side of the parentheses. M minus 2 is equal to 3M minus 30. Let's subtract M to both sides, and we'll also add 30 to both sides. This simplifies to 2M equals 28. Let's divide both sides by 2. So Miriam's age is equal to 14 years. She is 14 years old. Now we can solve for Ricardo's age. Ricardo's age is 10 years younger than Miriam's age, so I know Ricardo is going to be 14 minus 10, so he is only 4 years old. Question 9. The sum of two consecutive terms in the arithmetic sequence is 1, 4, 7, 10, and Question 9. The sum of two consecutive terms in the arithmetic sequence 1, 4, 7, 10, and so on is 299. Find these two terms. Let's give the first term a name. Let's call that x. And we'll call the second term y. We know that the sum of these two terms must be 299. X plus y is equal to 299. Now we have to look at the relationship between consecutive terms. We notice here that 1 plus 3 gives us 4, and 4 plus 3 again gives us 7. So the common difference is 3. That means x plus 3 has to be equal to y because they have a common difference of 3. This is great. This allows me to substitute x plus 3 into our first equation. X plus 3 should give us 299. Let's collect like terms. We have x plus x, that's 2x, plus 3 should be equal to 299. Let's subtract 3 to both sides, and 2x is equal to 296. We could divide both sides by 2, and x is equal to 148. So x is 148, but we also have to solve for y. To solve for y, I can plug 148 into our second equation here for the x. So x plus 3 is equal to y, and that means 148 plus 3 is equal to y. So y is equal to 151. So our two numbers are 148 and 151.